Here's a new paper, The Stability Principle of Planet Formation. I wrote a new Vixer paper up. And I keep these nice, simple, short, so the ideas don't get lost upon the viewers. I've been reading a lot of archive papers, and they're full of mumbo-jumbo, terminology, jingo, lingo, all these random terms, all these diagrams and graphs. And nobody really understands what they're talking about. They don't actually come out and say things in easily digestible bits and pieces. They just throw all the data out there and expect it to be understandable. I don't like to have that kind of approach with my papers. Abstract. Another principle of planet formation is added to the general theory of stellar metamorphosis. It is reasoned that planets can only form where the environment is stable for hundreds of millions of years. In stellar metamorphosis, stellar evolution is planet formation. Since planets form inside of stars, the planet is the remains of the evolved star. We can reason they form in very stable conditions that do not change dramatically over short periods of time. A short period of time in this case would be less than 100 million years. The interior of stars only change slowly in scales of tens of millions of years as they cool and die. Not only that, but they shield the planetary embryo forming in its center from gravitational instabilities and surface impacts. This means that any planet formation model that relies on gravitational instabilities and/or direct impacts to form it is misguided. This includes both the accepted leading scenarios, the disk gravitational instability model, which is a few hundred years, and the core accretion model, which is a few million years. Planet formation is an extremely gravitationally stable process. The planet embryo is also protected almost entirely, as the atmosphere of the star is too thick for smaller objects to interrupt the process in an unstable manner. Therefore, there are two main reasons why the stability principle supports stellar metamorphosis theory. The gravitation of the star remains very, very stable as it evolves, and the thick atmosphere protects the internal planetary embryo from significant impacts which might interrupt the process of planetary differentiation and physical deposition. It would be expected that if there was not a very thick atmosphere to protect the internal planetary embryo, there would not be an almost perfectly formed sphere of iron-nickel composite at the centers of highly evolved or dead stars. As well, it would be expected that if planet formation relied on instabilities of gravitation in a disk, then nothing would form at all. The instabilities would prevent anything stable from forming to begin with, and without physical mechanism for angular momentum loss, the disk instability model is dead on arrival. It says here below is a screenshot of the above references of the disk, gravitational instability, and core accretion models. And then I put a little screenshot from the archive paper. It's easy to spot out where they mess up with the archive papers, because they state their assumption right off the bat, and then boom, they try to build an entire paper off a false assumption. So naturally, it's a waste of time. If you have false assumptions, you're not going to have any meaningful interpretation of the objects in question. This is the Wolynski-Taylor Diagram. I don't like naming things for people, but it's Baz's idea, so I'm going to go with it. Here we have a very, very long scale of time here. And you have young stars right there, and you have old stars right there. And if you notice, stellar evolution is a very, very, very long scale process. See, 100 million years would be around where the orange dwarf is, right there, right on the very cusp of that. And then it goes down and it keeps on going. So to say these old ass objects, which are basically ancient beyond comprehension, form in an unstable fashion where it just, disks material just clumps together randomly within a few hundred years or even 5 million years, it's not to really look at reality for what it is. When people go to the Grand Canyon and they see the layers of the earth and how long it took something like that to form, they don't think, well, it just magically appeared here. No, it takes time to form really, really big objects. And the earth is the largest physical object that we have physical contact with. It's literally everything. It's the world, basically, to us. And to look at it and say, well, this thing just clumped together from dust, I don't think that's the approach we should be taking for the 21st century. The earth is ancient. It's very, very, very old. And any model that says, well, it's instabilities, or it forms really quickly, or there's impacts and it was very violent, they're completely missing the point. Planet formation is a very, very time-consuming process. And it's a very stable process. The earth is a very stable object. I mean, look at the ground. It's common sense. Of course the earth is stable. Rocks are stable. The only instability is inside the minds of these crazy researchers who have their heads, you know where. Alright, I think I made this video long enough. Take it easy, y'all.